Hello, my name is Noemi Garcia, and I'm an undergraduate researcher at the University of California, Riverside, working under Dr. Yin. Today I'll be showing how to synthesize spinel-type lithium titanate and doing a resorcinol formaldehyde coating in order to make a carbon coating. The method that we'll perform is a controllable and scalable process to make lithium titanate anode material with an improved contact between the active material and the carbon.
In order to make the lithium titanate, we will need a 250 ml 3-neck round bottom flask, titania, deionized water, and lithium hydroxide. We first have to centrifuge the titania and disperse it completely in some of the 150 ml water measured out. While the titania is sonicating, we weigh out 1.5 grams of lithium hydroxide. We add some water and swirl to dissolve. After the titania is completely dispersed, we pour it into the RBF with the lithium hydroxide and add the rest of the 150 ml of water. We then put the RBF in the reflux condenser and let it stir at 600 rpm. We reflux it at 100 degrees Celsius for an hour and 15 minutes. After it has refluxed for an hour and 15 minutes, we let it cool and do 1 wash with water and 2 with ethanol, and then disperse it in 50 milliliters of ethanol. We then prepare to do the RF coating. The things we'll need are a 100 milliliter 3-neck round bottom flask, the reflux lithium titanate, deionized water, ammonia, C-tab, formaldehyde, and resorcinol. We first get 5 milliliters of the reflux lithium titanate added to a new centrifuge and add water to reduce the volume fraction of ethanol. After centrifuging and sonicating the lithium titanate with 29 milliliters of deionized water and putting it in the RBF, we measure out 0.1 milliliters of ammonia and add it to the RBF. We then add 1 milliliter of C-tab to the RBF. We then put the RBF in the reflux condenser and let it stir for 500 rpm and set it around 60 degrees Celsius. While the contacts are heating, we make our 0.5 milliliter resorcinol solution. Once the temperature has reached 60 degrees Celsius, we then add 70 microliters of formaldehyde and add 0.5 milliliters of the resorcinol. As you can see, when we add the resorcinol, we can see a slight color change from a white to a pale yellow. We then heat it at 60 degrees Celsius for an hour and 45 minutes. After a few minutes of heating, we can see the color has changed to a pale orange. As it continues heating, we can see the solution turn a darker orange. After the time is up, we can see that it has become a very deep brown-orange color, and we let it cool and do 3 washes with water and place it in the vacuum to dry. Here we have a TEM image of titanium particles after refluxing with lithium hydroxide. The TEM image shows the porous, flaky structure which is a common feature of hydrothermal titanate production. Here we have a TEM image after coating the lithium titanate with resorcinol and formaldehyde. The TEM image shows how the particles smooth out after the coating. Here we have a magnification of a particle, and we are able to see a thin layer of the RF coating. Here we have an image of the RF coated powder. Here's an image of the carbonized powder. After calcination with argon gas, we can see how the RF coated powder becomes carbonized. Here we have an XRD graph showing the titania after being refluxed with 1.5 grams of lithium hydroxide. After calcination of the sample reflux with lithium hydroxide, it leads to a pure phase lithium titanate. This XRD graph shows a comparison of commercial spinel-tap lithium titanate with our sample. As we can see, our sample is a very good match to the commercial spinel-tap lithium titanate.
By refluxing titania to make lithium titanate and then coating it with resorcinol and formaldehyde, it will produce a pure phase lithium titanate, which can then be calcined with argon gas to make a carbon coating. This method may result in a more beneficial battery anode material by improving conductivity. Thank you for watching.